Hi everyone, this is the final presentation for EEL6825. I'm Rong Fan. My project topic is spam email filtering. This is the outline of this presentation. I will talk about 5 parts. First is the introduction to the spam filtering problem. Second is the algorithm I have used. Third is my design of spam filter. Fourth is the experiment results, and last is the summary. Now, what is spam filtering? We all have been annoyed by the hundreds of spam emails in our inbox day by day, which are full of unwanted advertisements. So, a spam filter is a program that is used to detect unsolicited and unwanted emails and to prevent those messages from getting to a user's inbox. Now let's talk about the basic algorithms I have used for this design. First is the naive Bayes. Naive Bayes is to say that we have the classification C. In this case, we only have to classify the spam email and the non-spam email, so we only have two classifications, C1 and C2. And for each email, which in this case is a file X, has n features from W1, W2 to Wn. And the posterior possibility of the file X belongs to classification C, Cj is shown here. And Px equals to this. In spam filtering, since we only have two classifications, we could say that the possibility of file X belongs to C1 is equal to this. And since in naive Bayes, we assume that all of the features from W1 to Wn are mutually independent, so we could get this formula here. With this, we could say that if the posterior possibility of file X belongs to C1 is larger than file X belongs to C2, we could say that the file X belongs to C1 classification. In this case, the file X is a spam email. Or if the file X belongs to C1, the posterior possibility of file X belongs to C1 is smaller than the posterior possibility of file X belongs to C2, we could say that the file X belongs to classification C2 and is a non-spam email. I have used 3 different methods based on naive Bayes to build my spam filter. First is the Gaussian naive Bayes. Gaussian naive Bayes means that the likelihood of features are assumed as Gaussian, and the posterior possibility is shown here. The second method I used is called multinomial naive Bayes. Multinomial naive Bayes is another kind of naive Bayes, which is widely used in the text classification. Multinomial naive Bayes is based on the occurring frequency of words to make predictions. And the formula is shown here. For each X, distribution is parametrized through vectors theta y. N is the number of classes. In this case, is the length of words. Theta yi is the possibility that sample X with label I belongs to class Y. And here, the NYI represents how many X with label I in T samples belongs to Y. And NYI represents for how many times class Y have occurred in all labels. Third method I have used is called Bernoulli naive Bayes. Bernoulli naive Bayes is another algorithm to solve text classification problems. It is implemented for data distributed in multivariate Bernoulli distribution. For example, a sample might have several features, and each is assumed to be a binary value 0 or 1. Therefore, this kind of sample is represented as binary value eigenvectors. And here is a rule of Bernoulli algorithm. In task classification, word existence vector will be used instead of word count vectors to train and use a Bernoulli naive Bayes classifier. The second algorithm I have used for the spam filtering problem is called support vector machine. Support vector machine maps the vector to a higher dimensional space and then establish a hyperplane with maximum distance. On the two sides of the hyperplane which divides the data, there are two multi-parallel hyperplanes, which divide the hyperplane and maximum the distance between the two hyperplanes. As we could see from this picture, both A and B could be the hyperplane which divides the two parallel hyperplanes and divides the support vectors. However, there is only one hyperplane which could have the largest margin, and we call it optimal hyperplane. This hyperplane could best divide the support vectors into two groups. This is the formula of support vector machine. What we're going to do here is to find the theta to minimize this. Now let's talk about my design of the spam filtering. There are 4 steps for me to establish the spam filter. First is the precise of the datasets. Second is to establish a word dictionary. Third is the feature extraction procedure, and last is to train. I have used 2 datasets for this experiment, the lean spam corpus and Euro spam corpus. For lean spam corpus, there are in total 1,490 emails, and I have used 1,000 to train and 500 to test. For Euro spam, there are 32,000 emails, and I have used 20,000 to train and 10,000 to test. All of the input files are in TXT format. Here is a screenshot of what it looks like in the TXT file. This is like the emails we have received every day, and we could see that there are some special characters and some punctuations. We do not want them in the classifier. We do not, because they have no contribute to whether this email is spam or not. So this step is to remove these special characters for the future classifier. Now the second step is to establish the word dictionary. In this step, I'm going to extract each word from the dictionary, from the emails in the training set, and also count how many times each word has occurred in the whole training set. This is a result of the word dictionary I have built. I have chosen the most common 3,000 words from the whole word dictionary for the future training for the models. This is the third step. It's called feature extraction. Now we have all the files without the special characters, and we have the dictionary with the 3,000 most common words which have occurred in the whole training dataset. What I'm going to do in this step is to see how many times each word has occurred in each of these emails. So the rows represents for each of the emails, and the columns represents for each of the word. And as we could see from the result here, 0 means that this word has not occurred in this email, and 1 represents for this word has occurred once in this email. 26 represents for this word has occurred 26 times in this email. The last step is to train. I have used the algorithm directly from the sklearn library, and I have used these 4 methods: the linear SVC, multinomial naive Bayes, Gaussian naive Bayes, and Bernoulli naive Bayes. Here is how I train these 4 models and print the results out. Here is a screenshot of the results. Now let's take a look at the results. This is the results for the link-spam corpus. As we could see here, this is the accuracy of the 4 different methods. It is obviously that support vector machine has the best accuracy than the others. However, these 2 are not bad, but Bernoulli naive Bayes is clearly not suitable for the link-spam corpus. And this is the FE score. The more close FE score is to 1, it means that the model is doing a good job. So also, like the accuracy rate, support vector machine has done a great job here. These are the results for the Eurospam corpus. It is not like this one that the Bernoulli naive Bayes have done a great job here, but the not multinomial naive Bayes does not have a good result. And as for the FE score, both Bernoulli naive Bayes and support vector machine are great. So, as we could see from the results, I would like to say that for this spam email filtering problem, I would like to recommend first to use the support vector machine algorithm, because for both the datasets, it shows a great performance. And maybe we should try several different methods from naive Bayes, because for different datasets, it may have different performance. So it's hard to say that which one is much better than the other. Here's a summary. According to the results, the spam filtering classifier for the link spam corpus dataset has a much better performance than the Eurospam corpus dataset. Because we could see here that for link spam corpus, support vector machine has an accuracy of 0.97. But for the Eurospam corpus dataset, the support vector machine only have a 0.90 accuracy. So we could say that for the link spam corpus dataset, it has a much better performance than the Eurospam corpus dataset. From my point of view, the reason of this result may be the size of the dictionary is not big enough for the Eurospam corpus dataset, or the dataset of link spam corpus is not big enough, and the parameters of support vector machine may not be the most suitable for the Eurospam corpus dataset. So in the future, more work should be done in the above areas to explore more possibilities in spam filtering technique. And now let's take a look at the program.